So welcome everybody. This is the first event of 2026 of AI Switzerland community. So welcome to the office of, thanks for Charles to host us, because today we are in the office of Exponent. And that's the reason why we could host only 25 people you see from the space. But we are working to find a place that can host more people so that you can also be on the presentation live and ask directly the question to the speakers, which is always a little bit better to touch and feel directly the speaker and his experience. Today we start with Reza, which has experience in Nestlé, and he comes from APFL. So today we'll speak about multi-agent, so how to build a team of agents that work for you, and he will present some use cases. So welcome, Reza, and I give you the floor.
Thank you very much. Thanks for having me today. I'm very happy to be here in front of all of these amazing people. So today we're going to talk about multi-agent systems, and in particular, why do we want to have those systems? What's the difference between agentic AI? And also to see few patterns and to see few results of using multi-agent versus single agent. So I just want to have a feeling of, because I was told that it's not very technical, the audience, so I just try to, adapt to see how much I should go into the depth. So people who are here, if you have been coding with any language, can you just raise your hand? Okay, so we have a lot of people. Python, JavaScript, TypeScript. Okay, C++, the other languages. Okay, good. So we have a good diversity. And also from the audience online, if you want, you can also raise your hands. I can see it here. So, and how many of you have been working specifically with agentic AI? Okay, so it's almost the same group of people who have been coding. But maybe one of the, let's say, outcomes of today could be that you don't need to be like a coder to use multi-agent AI systems today. And then I will go, if there's enough time and interest, I will go also to explain what tools we can use. So a little bit about myself. So I'm Reza. I have graduated from EPFL, worked 5 years plus in enterprise AI in Nestlé, and then I started Marsis, founded Marsis end of last year. So we are very early stage startup, and the idea of Marsis is that we want to build AI teams that they can think, learn, and work together. And when we say learn, it's also about the context of the business. So it's not a generic AI that they can, like it's the first day that it's working on the business. So just a little bit of, about the market. So this is like a report from Gartner, which showed like from Q1 2024 until Q2 2025, we had more than 1,400% surge in interest of using agentic AI in general. And then, so this report also mentions the trend in the industry that they're going to be 70%, around 70% by 2027, that there will be specialized agents compared to, generalist agents that we have mostly today. And also, there will be a lot of hurdles for the more, let's say, agentic AI. It also includes multi-agent systems as well. So it's not all a rainbow with multi-agents. So there should be also a lot of guardrails, how we can, make sure that the systems are not hallucinating, and many other reliability issues that we will see. So these are like predictions from future. So to show that it's, it's a real industry movement, not just, hype, and also there are some risks associated to that. So if you look at a major AI lab today, so OpenAI, Anthropic, Google, Microsoft, they all have their own agentic systems, and they're moving towards multi-agentic systems. So if you have been using, for example, Agent SDK from OpenAI, you know that it's like a work flow type of agentic system. There are multiple agents that they can work one after another or in different patterns. There's also Anthropic with its Agents SDK. And also, if you have been using Cloud Code, I'm sure there are many people also using Cloud Code. They introduced sub-agents in Cloud Code, which is like a coordinator and worker pattern in multi-agent system. Google Agent Development Kit, A2A protocol they introduced last year. And also Microsoft with their agent framework on Azure, and also AutoGen, which is an open source framework. So there are also a lot of other open source projects like LangChain, CrewAI. There are much more than from also new players that they're coming into play. And like Marsys, just to explain what is the difference between Marsys with all of the other agentic systems, it's that we have specialized agents, and then the collaboration framework is flexible. It's not rigid, but you can also add rules. Yeah.
Is there a way just to reduce this?
Oh, thanks. Yeah.
Just a tiny bit.
I thought that.
Yeah, you can rotate.
Yeah.
Perfect.
And then, so it's like a very flexible workflow. You can almost, translate any type of business workflow into this flexible collaboration. There is a smart context management, which also helps in terms of the learning business context and also the self-improvement aspect of the agents. And we focus mainly on the knowledge-intensive research. So this is our main differentiation. So just going to what is a AI agent in general. So if you have any questions, just you can drop me in the middle of the presentation. We can have this more interactively than just you listening, me speaking. So just feel free to raise your hand if you have any questions. And I don't know who sees it from the audience online. If
I can also
yeah, okay. Yeah. So if you're online, you can also write your questions if there is any question.
And for the people in the audience, just raise your hands. We have a microphone so people can hear you online.
Great. So AI agents, many of you, as you raise your hand, I know you already know, so I try to quickly move forward, but I just want to also have other people to have a same understanding of what is an AI agent. I'm sure there are different ways to define an AI agent, but this is how I'd like to define it, and I think it makes sense. So we have at the heart of the agentic AI, we have LLM, of course, as we all know, to make decisions, to reason. And then we have memory and context, which is recently being added to many of these agentic frameworks. So it's how we manage context. And if you don't know what is context in particular, it's what goes inside LLM. So it's all of the information that we add at the beginning, and then we add also our user request or whatever that you ask. So for example, if you want to imagine ChatGPT, you write a command to ChatGPT, but behind the scene, there are a lot of things that also being added before your request, like how it should respond, what are the tools that it can use. All of these things is part of the context management. And as you work, maybe you have experience like with Cloud AI online, or sometimes also with ChatGPT, you see that the context is full and you can't continue. So those are the things about context management, which again, there are a lot of improvements that are happening. And then we have tools. So these LLMs, they have access to external environment. Most of them are tools that their API search, like if it's on Bash tools, they can invoke all of those tools. And then we put all of these into a loop, and then we let it run. So that's like the difference between LLM before and agentic AI. It's just a loop that we let the agent run until there is no tool call or there is a stop condition, which you can also put in place. So any questions? I think it's pretty clear. So, but what are the limitations? What are the limitations with this pattern that I showed here? LLM, memory, tools, and then let it run in a loop. So there are a lot of things that can go wrong. The first thing is what they call context degradation or context rot. So context rot is it's something that you might have heard that, you know, I don't know, GPT-5 has 400K token context. Or for example, Claude has recently Claude Sonnet, it has 1 million contexts. But what it means is that that's the maximum context, or let's say a proxy of number of words that you can put into the LLM before it stops responding. But the reality is that much before that maximum length, everything starts degrading. The model performance starts degrading. You might see hallucination. You might see, I don't know how many of you worked like with ChatGPT or Codex or Cloud Code that when you say, hey, what are you doing? And then it responds that you're absolutely right. So that's, you know, the time that you should say, okay, this is something that I need to rethink how much context I put into my prompt. So the thing that, you know, there are a lot of research that has been done in the past 1 or 2 years. So for example, I think it was 2023 that this context of this concept of lost in the middle was introduced, which shows that, you know, if you put a piece of information at the beginning of the, let's say, I don't know, 100,000 words that you put into the LLM, if you put it at the beginning versus towards the end versus in the middle, like the reasoning over that specific information is not the same. So if you put it in the middle, LLM has a hard time to find it, to reason over it. And that's what they call this U-shaped curve. So the performance drops when it goes in the middle. So usually LLM is very good at the beginning, which you have all of the system prompts and instructions, and then at the end, which is the last messages that you have been working with the LLM. Yes.
Live mode.
They keep changing the models all the time. So like before it was like a more transformer-based approach, then became more like state-space models, like Mamba, etc. All of them are different architecture. Now they are going hybrid. There are new methods also every month. So I think this changes also how the context growth will change, because
absolutely, I totally agree. I mean, I haven't seen a lot of status models that they are commercial now, and also the every new generation, like Gemini 3, these lost in the middle, which is also needle in a haystack in the literature, they have been almost solving that, but it's something just to be, you know, aware. It's some of the, you know, very nature of transformers, because they have to do this pairwise attention between different tokens. So it's it will be there, but yeah, that's true. They're having a lot of improvement to you know, fix this problem. I would say needle in the haystack. I will show in the next picture, which is this one, almost solved. I agree. So. But this is still, you know, for very simple problem. Like to find one, let's say, piece of information, single piece of information from all of these contexts. So just for people to have an understanding, here we have the input length. So you have number of tokens inside the LLM, and then here you have the score in terms of performance. So the higher it is, the better. So what we see is that as you add, you see that, you know, for very simple tasks now, like this is a needle in a haystack problem. So it has been almost fixed. Then you have linear complexity, which you are trying to reason over specific parts of the documents. Then you have this type of drop in the performance, which is very high. But also, when you have this quadratic complexity, which is the Ulang pair type of problems, So you want to reason over multiple things, and you need to find these multiple things from different parts of your context to be able to reason. So for example, I don't know, if it's a legal document, there are a lot of internal, references. So you find that it's like a clause that it has been referenced. So you need to go back to find that clause from somewhere else. So these are like quadratic complexities. And you see that like from 33K, almost reaches 0, like the performance, which is, so this is like, for people who don't know, this is like a paper which had a lot of, hype recently. It's published in December 2025, so like 1.5 months ago. And it's called Recursive Language Models. So for people who are interested, you can go have a look to see what is their solution to improve this type of drop. And just a spoiler, it's using recursively, like having this hierarchical type of agents. They don't call it multi-agent, but in a sense, it's a multi-agent that one agent invokes other agents to find different parts of, let's say, information from the whole context. So that was just for me to make sure that everybody understands. If you have questions, let me know. If you have any specific.
In this case, did they have
Live mode.
In this case, did they have only a simple vector index like RAG, or like now they're also like implementing?
No, they don't use RAG.
Just the context they give.
Yes,
Okay.
it's just letting the LLM to write code. And then with that
And these are all code.
No, here there is no code. Here just single
talking about
agent.
that.
This plot is single agent, right? So you just ask GPT-5, for example, what they tested, and they put more and more context to see how much performance drops.
So it's a one shot. So you give maybe.
I don't think it's a
200,000.
one shot. Probably they do one pass like over multiple iterations, but yeah, it's like a single instance. Yeah, like single agent. It runs. It can run.
When you do like a multiple turn conversation, each time it gets with RAG, and then it can keep fresh. But if it's like there is no grounding, then of course it might fall. But I guess these benchmarks don't take into that dimension into account.
I'm not sure, because I agree it's like a different type of problem when you have in real world. But I think one thing that is clear is that whether you have user interaction, I mean, the only way that you can keep it high is that you constantly, tell LLM like this is not right, this is not right, this is. So we want to avoid that. But yeah, you're right. If you have like a verifier, like human verifier that takes this into account and explain LLM at each step, yeah, we can keep it high. And I'm sure also, maybe you have seen that that Anthropic like released a plot. It was similar to that, but they showed like Claude users, they have like since they interact, the same thing that you mentioned, they can keep the performance very high when they have a long context compared to like when people are using Claude API, which probably there is more automation and the performance drops fast. So yeah. That's true. And just the rule of thumb, I mean, there has been a lot of reports, people in the industry, and also firsthand I experienced, like if you go above like 70%, I mean, it's not a thief, but if you go over that, you will notice that the performance drop is very significant. So like if you have been working with Cloud Code, you see that if it reaches 80%, it starts auto-compaction. So what are, so one of the other things that is a problem with this single agent AI is that since if they need to run for a long horizon task, they need to reconstruct states because they have this summarization that is happening when the context gets very long, and that has an impact into how much we lose context and how much the performance drops. And I explained like what is the solution in multi-agent, but in single agent we have this. It's also like over ambition from the agent, like from the LLM side, which is you know, when you ask a complex task, it tries to do everything in one shot. I don't know if you ask like creates like a, I don't know, Instagram you know, duplicate for me, something like that. When you ask very complex tasks, it tries to one shot and it fails because it doesn't have this granularity that we can define into multi-agent systems. It's also about premature completion. So when you have this long-running task, the agent does some part of this progress. Then we compact the context and says, hey, this is ready. And then when you go to test the system, you see there are multiple tasks that is incomplete. This specifically shows when you are using it for coding, but also for other types of things. For example, if you want to do a deep research and you wanted to do research in 3-4 different areas, some areas just hallucinates and says, yes, I found a lot of, you know, research, and then tries to hallucinate the report. This is also related to the previous problem, which is this hallucination cascading, which is like the compounding error. So if you have a system that has, I don't know, 95% accuracy at each step like on average, then as you run this for more and more tasks, the accuracy drops because each time you have only 95% chance of success, and those 5% of errors, those compounds over multiple steps. So for people who want to read more, also there are some sources that you can read more about these problems into single agent AI. The third problem is too many tools. So if you know, there are a lot of tools that you can use, and there are a lot of MCP servers that you can use. So I mean, MCP servers, for people who don't know, these are like connections that you can have with your LLM from outside environment that you can ask to, that LLM can see them as a tool, and then it can ask to perform part of the task or part of the data, to retrieve part of the data from external sources. And the problem is that now we have too many tools. So for example, for use case in Marxis, we might have 50 to 70 different tools that we need to call. And if you put all of those tools into like the system prompt, the LLM starts making incorrect tool calls because it doesn't know which tool it should use. Then it might hallucinate the parameter. Like you want to have an integer, it thinks it's a string, or many other hallucinations that might happen when it chooses a specific parameter. And also the interference between tools. So for example, we have a browser agent in Marxis, and you have so many tools like a scroll up, a scroll down, and then you have key input, you have a special characters that they can use like enter or other things. And it gets confused if you put all of those tools together, specifically from different areas. Like you have, I don't know, a lot of tasks like browser agents that goes to the browser and automates a lot of tasks. You have part of the agent that needs to, for example, write a report. You have some agent that needs to, you know, validate. And if you put all of these roles together, you have this tool interference that can happen. And with so here are, you know, few numbers. I forgot to add the sources, but I will add sources after this talk. But the performance drop is very significant when you have more than 50 tools. So this is for more than 50 tools, and it's recommended to always keep less than 20 tools in a single instance. There are other, you know, solutions apart from using multi-agent, which is like, for example, dynamic tool selection, which Cloud Code has now. But it's, you know, it's always good to use less than 20 tools inside each instance. And then we have the compounding error, which I mentioned briefly. So it happens from two sides. One is that you have generalist agents, which they don't, you don't give a specific, for example, prompt for the use case, or you use the same agent, like the underlying LLM for all of the tasks. So that could, make problem, because it might be good at one type of task, but might not be good at another type. For example, I don't know, GPT-5, very good at reasoning, but maybe for code implementation, it's not that good. And you can have, fine-tuned models for being specialized if you want to have that, and that makes also even more huge difference. Just to give you like a number, like if you have per step reliability of 95% over 20 steps, and just on average, for example, for Marcy's, each workflow, there is between 200 to 300 steps. So if you just have 95% reliability over 20 steps, you drop to 36% reliability, just by law of mathematics. So you just multiply them together, and if you have 90%, then you have after 10 step 35% reliability. So in production, you usually need to have much more than like 99.9%, and this is like what we need to let's say to target when we want to have reliable agentic systems that they run on production. Yeah.
Live mode.
Just wanted to ask, by step, you mean a simple prompt in ChatGPT, or is something more complex?
No, for example, even in ChatGPT, because they're now moving towards being more agentic. So if you have, for example, if you ask ChatGPT, go search what are the events that are happening in Geneva next week, it makes multiple calls. So each of those steps that it needs to make, those are like one step. So it's not one iteration with you as a human. And if you make it automated, so the goal is that how much we can go before human needs to intervene. And the goal is that we don't have human intervention. So what would be the reliability of the model? So of the whole system. Yeah.
And like these steps are present only in reasoning model when there is like a chain of thought, or also
you can have like non-thinking models as well, but the problem is that the performance is much lower for non-reasoning. Yeah.
Okay, thank you.
You're welcome.
Bluetooth mode.
So now we enter like multi-agent systems. That was a very long introduction to say why multi-agent systems. So multi-agent system, what is it? So it's like, again, as the name implies, there are multiple specialized agents. They work together. They define the whole orchestration, how they can interact with each other, who it can interact, like each agent with what other agents it can interact. So each agent, they have their own context, they have their own tool, and they have their own specific instructions. You can also have a different model. So one agent has, for example, GPT-5, another has CROTs on it. Or if you have local models that you fine-tune, you have different versions of that fine-tuned models. And so, for example, this is like the most used type of pattern. So you have one coordinator which plans, delegates tasks to other agents, monitors the, the progress, and also coordinates. And then you have different sub-agents. For example, here we have, let's say for a deep research, you have researcher, which the job is to gather information. Then you have analyst, which, synthesizes and tries to put different pieces of information together. Then you have writer, which writes the final report. And then you might need also a reviewer to fact check if there is, reference to a specific source. And each of them, the coordinator starts, decides which agent to invoke at each point of time. So this is like under the hood of many agentic systems, like even ChatGPT, when you enable deep research. They have multiple agents that it runs under the hood. Cloud, for example, Cloud Code, if you have been working with that, if you use sub-agents in Cloud Code, it's exactly the same thing. There's main loop, which is the coordinator, and then it invokes other sub-agents. So like these are very, let's say, common patterns and architecture in multi-agent systems. So on the left, you have the coordinator, which many of these agentic systems, they work like this. They also call, I mean, there is another, let's say, expansion of this type of models, which you can have, which is like hierarchical models, that this can expand like a tree. So each of those like agents here, so this is like coordinator, researcher, and all of the other agents. So each of them, they can also coordinate multiple agents. So this can grow. Then you have like parallel. So it's like one agent invokes all three agents at the same time, and we aggregate the result. And then there is like a reviewer or reporter that gathers all of those results together. And then we have sequential as well, which like there are multiple agents, but we start invoking them one after another. Yeah.
Live mode.
So maybe last time I checked this a year ago, what we were doing, like carrying the entire chat history to a new agent, because you have to give it enough context. Maybe now it's more efficient to give context from agent A to agent B, or like when we have different finance strategies, each agent might have different subcategory of the information so far the supervisor has. So currently, is there like what kind of strategy like do you guys follow?
For passing context?
Yeah, yes, between agents.
It depends on the multi-agent system that you use. So like for LangChain, as far as I know, they share the whole context. There's like Google ADK, which, if I'm not mistaken, the context is passed by the choice of the coordinator, for example. It chooses what kind of information it wants to pass to the next agent.
So is it massage context, or like just directly the chat copy pasted kind of, you know?
You mean that if the agent outputs the token to give the context, or it can reference to a part of the chat and then that chat copy paste to the next agent?
Exactly.
So so that's context passing. In Marsis, for example, we have that. So like for other agentic frameworks, I'm not sure if that's the case. Like I'm sure you can implement custom like context passing in LangChain, I mean LangGraph, let's say. So you can do very complex, context passing, but you need to write the code, and then you need to tell the agent how you expect the agent to point out to those parts of the context that you want to pass. There's also another way, which many of these agentic frameworks like Manus, I don't know how many of you work with Manus. So it's like very no-code, user-friendly. You just input your request, and it does all of the things under the hood. You see, of course, what it's doing, but you don't need to code anyway. And for example, Manus, they work like, they use file structure. So it's like first agent, we also do that in Marsis. So first agent, it writes into a markdown file, for example, the research, and then it passes just the file path to the next agent. And then that agent can read the part of information that it needs, or it can just, quickly scan based on the structure. So if it's a long PDF, for example, in Marsis, we provide like an overview of the whole PDF, and then it can also go into more detail to read the chunk of the PDF that it needs. But that's different strategies on how you pass the context, and it depends on the agentic system that you choose or you build. There are different ways. So each of them, they have different, pros and cons. So for example, the coordinator is very easy to debug. And if you have like nested parallel agents, I don't know how much you work with them, but they are very hard to debug. So if something goes wrong, you need to scratch your head for hours to understand what is going on under the hood. No matter how much you log the report, the agent progress and the steps, it's really hard to debug. And sequential, it's also very easy to debug, but it takes more time because each step, it needs to go one after another. And also, if you need to have a validator that checks if the result is high quality, if not, to send it back to the previous agent, that could also be a problem. But like theoretically, you can put another, let's say arrow from the last agent to the first agent if you need that. But sequentially, usually it doesn't. You don't have that, go back arrow. And then coordination, a coordinator method, for example, it's transparent, easy to debug, but latency and also time to implement, time to run is a bottleneck. So if you have been working with this type of coordinator worker method, you know that they can take a long time. So let's say the ideal solution is that when you have your workflow, you can map out which parts you can run in parallel. So if you, for example, need to do risk assessment, and then at the same time you need to also read some legal documents and they are independent from each other, you don't need to wait one after another. You can just invoke all of them together. And if you're using a solution that they are proposing any of these architectures, maybe for your business or in your work, then you already know that what are the different pros and cons about each of them. And so the first thing that we mentioned is context route. And the first thing that I show also in multi-agent solution that can answer is also context. So you have different agents. They have fresh context when they are running, and they can focus on the specific task that you're giving it to them. So for example, if you have single agent and you have 100 to 200 tokens in one agent, now you can divide those into, let's say, 5 to 10 different agents, and then you can have each of those agents have, let's say, 20, 30K context instead of like those gigantic contexts that you need to deal with. It's also easy to stay on track. I will explain later, and it makes context engineering very simple. Not very simple, but easier than the single agentic solutions. And one thing that let's say if you want to use these multi-agent systems, context is also one of the way that we try to understand how we should break down the whole workflow into different agents or let's say multiple agents. And let's say the guideline here is that you want to have the minimal context that doesn't prevent the agent to perform its task. So it's like the smaller that you can have the task defined for agent, the better the output. But you need to make sure that the agent has enough context to work with the task that you're asking it. So any questions, any points that you want to raise?
Live mode.
So just to know, in practice, how do you do this context isolation? Do you have like one tool whose job is to like isolate context and distribute it to the specialized other tools, or?
For example, let's say I use this task for creating the slides as well. So let's say you want to find some literature. So there is a research agent. Then you want to have an analysis agent that analyzes the research that has been performed. And then you have the final agent that creates the slides, right? So if you put all of these things together, for example, for the research step, you might look into a lot of sources that are not very relevant. But if you keep it into the agent, like single agent context, you have all of those things also existing into the analysis step, also existing into the last step. But if you break down into 3 different agents, there is like a coordinator that gives like a general description of the task, what you want to research. So the researcher makes all of those research, saves it into a file, or returns like a 1-2 page summary of the results that it found, and then it gets passed only the useful part to the next agent. So all of those intermediate steps that you don't care, they're just noise. You cut them out from the next agent and after. So this is like, naturally you have this context isolation in multi-agent system. You don't need to do anything unless, like LangChain, you have a context being passed to the whole like pipeline. But yeah, that's something that comes naturally with multi-agent system. And then you make a choice how you want to pass the useful context, as you mentioned before. So for example, we can have this file sharing that you write to a file and then you share the path to the file. So the next agent can only search to find relevant information and not even to read the whole file. And there are multiple ways to manage that. And so next is that you give the right tool to the right agent, right? So context is one of the way that it guides to break down like a simple, complex task into more simple steps. Tools also is the same thing, that when you are looking for, multi-agentic system to see how you can, if you have a complex, business logic and you want to automate, or if you have a complex task that you do day to day and you want to use a multi-agent system, this is also another way that we look at. For example, you have browser agents that all of the tools are related for controlling browser, to clicking, to move the mouse pointer, to scroll up, down, etc. So, for example, for the instance that I gave an example, like researcher, there might be like 3-4 tools to web search, to fetch a web, to write, read from file. Then, like for data analysis, you might give like a Python executor to this to be able to run some code, also read some files. So you break down each of these tools into the different agents that they are working, and the result is that instead of putting all of the tool into one agent, you have separate agents that each of them, they have their own tools. And for example, there has been like a benchmark agent arc that was released in 2025, and they tested, for example, for Sonnet 4, Cloud Sonnet 4. So for multi-agents solution that they had, the performance on average was between 84 to 97, and then for single agent, the performance was 72 to 86. And the thing that they were testing was mainly also to see if the agent can make the right tool call. So that was like the function calling that they tested with the agent, and that's also very clear that the agent can improve the number of correct function calls. And in general, I mean, you can have now even up to like 20-30 tools, but above that, it's better not to put. And the best practice, keep it as small as possible, the number of tools that you want to give. Yeah.
Live mode.
So I have a question related to knowledge as well. So now we're focusing about tools, but did you see any use cases where, for vast amount of knowledge, where it could be, let's say, in a big enterprise, there is lots of different teams and they have lots of different expertise and knowledge. Would that make sense as well to separate it into a multi-agent RAG system, for instance, which knows where to distribute the tools?
Can you give me an example, for example?
So let's say bank XYZ has multiple departments: legal, marketing, front office, operations, tech. And all of the knowledge is just, for now, just put into one big vector database. And now we have an internal search engine. And
okay, I see. So even like for the retriever part.
Yeah. So have you seen any use cases like this online or on your side where? they divide into multi-agent and they separate the context or the knowledge so that
yes, yeah, because the way that you need to look at like legal documents is completely different
Bluetooth
from, for
mode.
example, if it's like a healthcare related document, or if it's like, I don't know, technical documents, completely different way of looking at, complete different way of retrieving that. So, for example, this hierarchical way that I introduced in few slides before, that's how you can even break down like a simple retrieval task into multiple phases or multiple agents. So for example, if your task has first find the right data, then make an analysis and finally write a report, or make an action into our internal solution, I don't know, change a customer registry or send an email, whatever. Then the first step, which is research, you can even break it down and have a specialized agents that they only have access to a specific type of database. And because I mean, this data isolation is also very like clear in big organizations. They have different databases. I mean, when I was in Nestle, we had like different Azure databases, that data lakes that we had. We had hot, you know, cold storage. We had different things, and each of them, if you want the agent to use, they need to have different tools.
Okay, and maybe just to continue on that note, because so far what I've seen here is more like we try to separate the knowledge using, for instance, metadata filtering, where we would just orient the LLM to create the metadata filter based on a certain knowledge, and so we then restrict the knowledge based on that. But in your experience, or what have you seen that makes multi-agents better than metadata filtering, for instance, in this example? Maybe it's too precise.
When you say metadata filtering,
Bluetooth mode, lib mode.
So because you can also search on the specific patterns in the text, right? So for example, I mean, if you're looking for
Bluetooth
a pattern, let's say for a file search, if it's like a you know, data lake that you have different information in different documents, you can use grep, you know, to also search over the text.
Yeah,
but
no,
also
I was not meaning like a full text search. I meant like, for instance, we would put metadata labels on some data. For instance, let's say these are legal. Yeah, exactly. Yeah.
So
like this,
it's not only metadata, but if I understood your question, you can also go into the text. But if you're pushing more towards RAG, of course, you can have also a RAG agent that is only specifically working on a RAG database that you have for a specific, you know, task. And in another one, agent, maybe it's not even RAG. You know, it's just a simple search in a database with the SQL query, for example. That could also be the use case. But I think it's very specific to the type of data that you have. If it's like a collection of documents, like PDF files, if it's like a relational database, if it's different types, yes, of course. And for example, for RAG, the thing that makes sense is that you can chunk them into, you know, smaller, like each document you have different chunks, and you can retrieve the part of the chunk that it's related to your task. I mean, there has been a lot of, let's say, research and also a lot of articles that they are saying like RAG, when it comes to complexity, like for example, legal document, if you need to retrieve one chunk, you don't have the logical relation between what is your question and what you're retrieving. You have like the closest in terms of similarity of the semantic similarity. So the solution could be like graph RAG, that you have also this logical context between different entities that you have in your database in the RAG system. But I think, yeah, that's like a whole different topic. You can implement RAG in single agent, and you can implement into multi-agent as well. Yeah. So another thing is like experts, not generalists. As I mentioned, you know, you can choose different models. You can have, for example, Opus 4.5, which is like the top of the top line for Anthropic models, which is very good at reasoning, complex reasoning, coordination. It's very expensive. Like if you get like the output tokens, if I'm not mistaken, it's like $25 per 1 million token generated. And then for tasks that they don't need that type of complexity in reasoning, you can use Claude Sonnet. And for very simple tasks, for example, if you want to go and retrieve a data from web, you don't need to have even Sonnet. You can choose Haiku. So what happens is that you have a lot of reduction in cost. So like 40 to 60, what we have seen, in our systems, because you can choose a smaller model for simple tasks, and you work with less context in the end inside each of these tasks. And also, the difference between model performance is not that high. So if you see like the results between Bench, like for Sonnet and Haiku, it's like 73 versus 77. So if you have like a task that you can really leverage, this cost reduction, it makes very sense in terms of business to have lower cost, because for some complex tasks, you can have like 50 to 100, let's say CHF in terms of the task that you're running. So if you can save costs, that could add up and compound over the multiple, let's say 100 or thousands of requests that you need to have. Also, it's not just, let's say Claude or from Anthropic models, can mix and choose with any type of models that you want to have, even local models. Questions? Yeah.
Live mode.
Have you checked any other like smaller models, as you said, I was pointing from there, like Kuvan, etc. They were using, and then they add some LoRa adapters for specific use case. So you are specializing even smaller ones, but for your use case, and then maybe you can add then any RAG on top of it, because they say 2026 is the year of small language models, not like large.
Yeah. I agree. It's there are a lot of new models. I mean, I have seen, like, I think it came out yesterday, GLM 4.5, 4.7 Flash, which is amazing, like from the model size. I don't exactly know the parameter count, but it's a very good model. And imagine that if you fine tune it on your own task, can be even much better. There is, for example, Gemma function calling, which is like 370 million parameters. And if you just fine tune it on your own task, it can pretty much do a lot of the heavy lifting of the steps that you want to have. So yeah, absolutely. If you have a multi-agent system, you can have these specialized agents even running locally. And imagine if your business logic prevents the data going out. So if you need to have it in your system, then trying to have one model that does everything great, it's really hard. But yeah, you can focus on special steps. So one model is good at retrieving data, like RAG. Another model is very good at the other steps.
Yeah, I was doing this like very small language models for one company, but they are like 250 million parameters, and then they can't even like form proper sentences. They can just do multiple choice answer when you want to do classification, for example. But for example, in this case, like experts, not generalists, at some point, I guess people have to do also like specialized instances of Haiku for their company.
Yeah.
So then
right now they don't allow that, but yeah.
Yeah. The banks, they never do like a cloud, but
it'll be I'm sure there are a lot of things, like if there is sensitive data, like in healthcare, you can pass it to other models. Banks, there are many other like governments also things that they don't want to do that. So yeah, many of them, they need to have even air gap, like the system doesn't have access to the internet even, so it's all in their internal system servers. So that could be also very important when you want to have local models, small models, to be very specialist.
And you said GLM 4, 5, which came yesterday?
GLM 4.7, if I'm not wrong. It's like GLM 4.7 Flash.
Yeah, because every company, when they have to do this these days, like they release a model and then they do a benchmark, but the benchmark is like a rote like everybody has like tweaks to it a little bit, so that, oh, we are better actually, we are better.
Yes.
And so these days, the validity of the benchmarks also is like problem.
I remember that when GPT 5.2, they announced it. They announced that it's very good on Bench and all of these benchmarks. And then people started using that in their own cases, and they said it's even worse than GPT-5 for them. So yeah, I think there's a lot of overfitting to some of these
Bluetooth
benchmarks.
mode.
There's a lot of, I mean, they try to say that we don't have contamination in our pre-training, post-training. They try to exclude, but anyway, there will be some contamination. So yeah, that's true. Always true. Yeah.
So just 10 more minutes. Do you have more slides to present?
I can go fast. It's not that much. But also for parallel work, you can imagine that you can, reduce latency. If the latency is very important in your business, that could be very significant, the latency reduction. There are a lot of studies that they have been, trying to compare these things, and of course, you will get a lot of performance boost for parallel. And so I don't know if you use like Super Grok Heavy from XAI. So the only difference between Super Grok, which is like the Grok 4 now, 4.2, I think, versus like this Super Heavy, is that they have 4 instances of this, they run in parallel, and then they debate together until they converge to an answer. So even like in terms of improving performance, parallel agentic workload, they can have significant impact on the performance. And then also, is there any question? No. Also, it's like if you want to have an agent to verify the results of one agent or maybe multiple agents together, you can have that into multi-agentic without needing to say, but yeah, that's something that you can have as a result of this multi-agent architecture. And you can have also debates like in terms of the Super Grok Heavy case, you can have 4 agents, they debate together until they get to an answer, and it has been shown that it improves a lot into reducing the error that they make and also improving the performance. So also, you can, and this is something that I mentioned before, that multi-agent system is not answer to everything. Just the message here is that there are a lot of tasks that you should use single agent, and there's no reason to make it complicated, add more additional cost or make, extra effort to maintain a multi-agent system. But there are also a lot of cases where the accuracy, latency, cost even that are important. You need to have this type of multi-agent systems because you can define the business workflow that you have today in terms of the agentic workflow. So you can imagine that each of these agents are like a team member, that you give them a specific instruction and they have to follow, and also how they work together, they need to follow that. So the key takeaways is that there are some cases that single agent it hits limits like context degradation, tool overload, etc. that requires multi-agent systems. And multi-agent systems, it addresses most of these problems in various ways, as I described. There's also evidence that, it's very important to choose the right architecture when you want to have this type of agents for the right problem, so you benefit from the multi-agent approach. For example, for this debate, I think it's a very good example of having this parallel agents running together to reduce the error. And it's not magic. There are a lot of cases that you need to burn more tokens and more complexity. It might hurt if you have this sequential type of task, which I didn't discuss, but there are a lot of tasks that they need to run sequentially. There's no way that you can make them parallel. So might also hurt those type of tasks, but you need to be aware of the downside, but there are a lot of upsides for the multi-agent system. And anyway, this industry is moving to that way of working. All of these big AI labs, they are working on multi-agent solutions or one way or another. And I think there will be a lot of standards that they will introduce, like agent-to-agent, A2A standard, and many others that they will come out probably in the future that can improve the reliability of these systems. So thank you very much.
Live mode.
So thank you very much, Reza. I think there is time for 2-3 questions, but I would like to give maybe priority to people online if they pose some question, because we have the networking session here, so we can continue later. Nicola?
No questions so far online. Just feel free to pop it out on the chat. I can read it for you, or just raise your hand and unmute if you want to ask questions.
So in the meanwhile, while we are waiting.
Thank you very much. Just in the beginning of the presentation, you mentioned self-learning.
Yes.
I would like to know a bit more about this.
Yeah. So this is what we are working in Marsis. And there are different ways that we can have this self-improvement. So you can have like a signal from a user, like from the expert that is working. If let's assume like insurance claim processing, right? You can have these multi-agent systems that they run to process. Like as soon as there is a document that is submitted, it can go research the document, ask for more information until the whole pipeline goes to the end, and it makes like a decision whether to approve or decline the claim. And these are like something that you can sample, like the ones that you have high uncertainty. And there are many ways to define higher uncertainty in these type of solutions. But let's say you sample those, and then you have an expert to validate whether it agrees with the results or not. So you have a sort of human validation that you can reuse to either change the prompt in the instructions, if you can debug the system that there is one specific agent that is always making the mistake. So for example, the agent that needs to ask a specific questions from customer, for this case, it doesn't ask the right type of information, or maybe it doesn't wait for the customer to answer. So whatever specific thing that it is, you can drill down into the specific step, or you can retrain your language model, which is at the heart of this agentic solution. So you can retrain using that data. So we use like reinforcement learning for that. You can retrain to make it better. And then there's another way, which is like the cloud introduced recently, which we call skills. So skills is like the set of instruction plus tools plus everything that you can give to the agent to perform a specific task. For example, if it's like creating PowerPoint, you have a specific instructions for that, and you can improve this skill. It's like a way of working for the agent in a specific business context. So this is another way, and you can imagine that you can have like a self, reflection agent, which once the step is done, it self-reflects what was the problem, and then it can update these skills for each agent. And then the flow that we use is that we use this skills update to see if the result is improving. If it's improving, you can use that conditional, let's say, a skill to have an oral training on top of that. So it's like a combination of updating the skills, and then if you have a local model, you can also adapt that specific model. So that's how they can improve as they work into the specific task.
Live mode.
Yeah, you mentioned the reinforcement learning, so let me ask one question. Have you tried it, by the way? Like, did you try to get entire model weights to update, or like specific adapters?
Yeah, usually I use the entire model weight, and of course you can choose which layers you want to update, but you can also use adapters. That's also possible, but usually for oral, I use the entire model weight.
The entire, okay.
Yeah.
And then there is this like reinforcement learning with human feedback, which turns out to be not so good. And then this verifiable
with
reward
RLV or
one,
like
yeah.
verifiable models. Yes. So that's how you can also improve that. And then you can have like a synthetic data method that you generate, and then that's the ones that you have like the let's say success. So again, you can define success in different ways, and then you try to make those steps, the probability of those steps being taken by the model more by doing the reinforcement learning. So that's another thing. So for example, for browser agent, what we did was that we generated like around 1.5 million instances of these tasks, and then we try to do this RL training on top of that. It's just generic, like different types of tasks. So it's like the process was that we took like a very small subset of Find Web, and then we try to generate the task based on the website that we found on that Find Web subset, and then we generated like the steps that the agent needs to take, and the ones that they took and it resulted in success. Like for example, if there was a cookie pop-up, they needed to, you know, accept or reject. So this is, for example, various specific problem that many agentic solutions they don't do. So those are, you know, one of the things that you can find throughout all of those different paths to make the model better using R.
Live mode.
Right. Thank you a lot, Reza.
Thank you.
I'll just make a couple of closing notes. So a few things. Currently, we have a WhatsApp group which we have been asked to reset. Unfortunately for us, it's not really convenient because we are also sharing. It's coming from a network, Go Social. So to facilitate and to make sure we have continuity of our event, we're also using LinkedIn. And so we ask for you to follow this page. It might be easier. We share the videos. We'll share also the different events and the post-event comments from each event. The other thing is we might also create a new group in the future in WhatsApp. For now, we managed to continue this for the next few months, but we might need to ask you to migrate there. So that's a first note regarding communications. Second thing, we are experimenting also new venues. So we have a venue, or we had a venue which were in next to Plein Palais. This event at the moment, we will see if they're a bit better place where we can host more people because we are a growing community. There's also maybe easier if we have Wi-Fi, so we can actually share online and so on and so forth. So we are experimenting. So just to let you know, we might be in different venues in the coming weeks. Also, in terms of frequency, so we keep it every 2 weeks. So we'll continue on that frequency from now on. We'll see in the future if we change that. For now, it's just very convenient for all of us. And the final thing, we are starting to stream now online. So for people that still want to join, but won't have unfortunately the capability to do networking event right after, they still have the capability to watch the event. And we also record this, so there's also the possibility to watch it online later on once we publish into the different social networks. So that's it for me. Thank you all for joining. Thank you for the people online as well for joining. And we can continue on with the networking part. Thank you.